right. That's a blast from the past. That is a band called No Melon, or Blind Melon, excuse me, with a song called No Rain. And that song is way, way, way older than you guys. I mean, that was mid 90s when that came out. A little bit from my childhood. Felt like listening to that song a little bit, so I did. And if you knew what that song was, you're already pretty cool. So good for you. And if not, not a big deal. Go look it up. It's actually a great song. All right, so we're looking at the ping proof, okay? So if you're watching the other videos, maybe this is your first one. The very first step you should always do when you write a proof is make sure in your head you're very clear on why angle 3 and angle 4 are supplements. Well, what in the world does that even mean? If I'm saying angle 3 and angle 4 are supplements, we have to realize supplements is another word for supplementary or are supplementary. So what we're really trying to show is that the measurement of angle 3 plus the measurement of angle 4 is equal to 180 degrees. If we can show that, we're in business. Now, here's the deal. In the past, if two angles have been added to 180 degrees, they formed a line. But these can't form a line. Angle 4 is way over here. Angle 3 is way over there. So what can I do? Well, in the end, I just have to show their measurements are the same. Measurements, not the actual angles. That's why we've been preaching so much about keeping those things separate. 3 and 4 do not form a line, but they can still add to 180 degrees. Our job really is to somehow take this measurement of angle 3 and transfer it to the 2 position. If we can do that, because 2 and 4 make a line, then we're in business. Well, can I? Well, what am I given? I know that 1 is congruent to 2. Oh, look at this. 3 is congruent to 1 because of vertical angles. So if 3 is congruent to 1 and 1 is congruent to 2, 3 has to be congruent to 2 as well. That actually is going to be the way I transfer this measurement. Now, keep in mind, I did say measurement, but if angles are congruent, their measurements are automatically the same, so we're in business. We are good to go. If I can show that the measurement of 3 is the same as the measurement of 2, and 2 plus 4 equals 180, then 3 plus 4 have to equal 180. That's how I'm going to write this proof. Verticals first, and my givens, transition, linear pairs, show that angle 3 plus angle 4 is 180 degrees. That's how we got to do it. That's how we are going to do it. Let's get this done. So here's kind of the deal. People have overwhelmingly said in class that the preferred proofing style for them, the way they're understanding best, is going to be by writing a 2-column proof. So although that's not my personal favorite, and actually I don't like them that much, I'm going to write it that way. And I encourage you guys to do the same if that is your style. If not, if you're writing like a flow proof or maybe a paragraph proof, know that all the steps I'm about to list are all the steps you need anyway, so you can transfer it pretty easily. You can convert that. So let's make our 2 columns. I'm going to make them perfect. Look at this perfect line I drew here. Look at the perfect line I drew right here. Oh, yeah. If it's not straight, that's the problem with your computer monitor. Okay, so over here we have the statements. Another word for that is the what's. In other words, what are you trying to claim is going on? Over here are the justifications. In other words, a why. Are you sure that's actually true? We have stages in our proof. We have the vertical piece. We have the congruency piece here from the givens. We have a transition. We have a linear pair. And then we have some manipulation. I'm going to start with my givens. I mean, that's something I've always kind of done consistently. Now, it's not like a law. Like, it's not proof law that you have to start with your givens. But it's usually a good place to kind of jump off and start the proof. So angle 1 angle 1 is congruent to angle 2. That's given to me. I can just write given here. Look at that. We're already on our way. Angle 1 congruent to angle 2. I'm going to mark my diagram to help me kind of track where I am. I need to connect 3 to 2. I need to connect 1 and 3 right now. So 1 and 3, what structure do they have? Well, angle 1 is congruent to angle 3. And that's going to be because of the vertical angle theorem. So again, the structure of vertical angles gives us a relationship of congruency. Well, what do I know? Well, I'm trying to connect 3 to angle 2. I can do that now because I set myself up a transitive chain. 2 is congruent to 1. 1 is congruent to 3. Therefore, 2 has to be congruent to 3. So angle 2 congruent to angle 3. And that's going to be because of transition. Or the transitive property. They mean the same thing. Either one is equally good. Now, in the end, I do have to show that the measurement of angle 3 plus the measurement of angle 4 is 180. So I might want to transfer these to measurements now. In fact, I'm going to. But if I know they're congruent, I know their measurements are automatically the same. And hopefully this is becoming very easy to start picking out. This will make up as a definition of congruency. All right. So before I move to the next step, you may be asking yourself a really vital question, which is, hey, Mr. Collins, how come you decided to talk about the measurements in step 4, but you didn't talk about the measurements of 1 and 2 here, and you didn't talk about the measurements of 1 and 3 there? Well, two answers to that question. Number one is because I was using transition, and transition it doesn't care if it's transitioning structure or it's transitioning measurement. So measurement was actually unnecessary in this case. For example, like I can say, well, here's this iPhone 5, and that's equivalent to, let's say, a Galaxy S3. And the Galaxy S3 is the same as a new Motorola, Razr, whatever that kind of phone is. Therefore, the iPhone is the same as that Motorola. Has nothing to do with the measurements or the price. I'm just saying the phones themselves are congruent. They're the same. I can also do that with numbers. Like if I say 3 plus 1 is equal to 4, and 4 is the same as 2 plus 2, 3 plus 1 is equal to 2 plus 2. So transition does not need measurement or structure. It can do anything. Now, the second reason I didn't talk about measurement in this step, or the measurement of 1 and 3 in this step, is because, frankly, I don't care about angle 1 at all. I don't care about its measurement. I don't care where it is, what it is. All I care is that it linked angle 2 to angle 3. The measurement of angle 1 was unnecessary, so why even take up space doing it? Now, I saw a lot of people doing that in class, and I pointed out that it was very inefficient. It's not wrong. Like, if you want to talk about the measurement of angle 1 and the measurement of angle 2, measure angle 1, measure angle 3, and then transition using the measurements, you can. I would argue you're adding like 2 extra steps, but that's just me. I mean, whatever you guys see is up to you. Okay, either way, let's move on. So I got angle 3 into the 2 position, the measurement of those. Now I have to write an equation to actually get angle 4 in the mix. And the equation I'm going to write is based on the relationship of linear pairs. So we have to start with a structure. We always start with a structure. So I know that angle 2 and angle 3 are supplementary, and I'll abbreviate supplementary, and that's going to be because of the linear pair postulate. In other words, hey, angle 2 and angle 4 form a line, therefore they're supplementary. So structure drives relationship. Relationship, supplementary, drives the equation. Measure of angle 2 plus a measure of angle 3 equals 180 degrees. We know that because of the definition of supplementary is what it means to be supplementary. I'm so close. I mean, look what we had to prove. We had to prove that 3 and 4 are supplements, which really means I have to show that a measurement of 3 plus a measurement of 4 is 180. I have 3 in an addition problem equaling 180. I just need to get rid of this angle 2 and replace it with an angle 4. Oh, I messed up. Excuse me. Let me go back here. I need to change something really fast. I don't know why I did this. That's angle 2 and angle 4 are supplementary. That's 2 and 4 supplementary. I apologize, guys. The last minute and a half, you guys are probably like, what in the heck is going on? 2 and 3 aren't supplementary. I apologize. Let me back way up. This should have said angle 2 plus and angle 4 are supplementary. That's what's going on right here. Therefore, angle 2 and angle 4 add together to make 180 degrees. Again, I 100% apologize. If you were just watching that for the last minute, you're probably confused. Please, oh please, go back, change that, accept my apology. So 2 and 4. Anyway, what we were saying before didn't change. I need to take out 2 and replace it with 3. I can do that because in step 3 I established that. So let's show that in step 7. So the measure of angle 3 plus the measure of angle 4 equals 180 degrees. And that's going to be because of substitution. And we just took out 2 and put in 3 in its place. Okay. Well, if they add together, the measurements add together make 180 degrees, and by definition of what it means to be supplementary, we can say angle 3 and angle 4 are supplementary. Okay, and that's by, again, definition of supplementary. Okay, and we are done because that's what actually we had to prove. Again, I'm so sorry for that, guys. I just was not paying attention. I was going too fast. But step 5 should have read angle 2 angle 2 and angle 4 are supplementary. Therefore, the measure of angle 2 plus a measure of angle 4 equals 180 degrees. So if I cause some confusion there, I apologize. Please accept that apology. I'm fixing it right now. Okay. So transition 3 to 2, linear pair 2 and 4, show the measurements 180, therefore supplementary. There you go. Again, great proof to study. Thank you so much for studying with us tonight. Again, if you have additional questions, please post on Edmodo. Edmodo does have the ability for you guys to upload files, I believe, so you could definitely upload if it's hard for you to ask and type out. I say take a video really quick of the question you're trying to ask and upload it, and we can look at it. We can try to answer your question. I'm going to be monitoring that site pretty closely tonight, looking for notifications, looking for postings, and trying to answer as many questions as I can. Good luck studying. There's Ms. V calling for Activity Bus. But anyway, good luck tonight studying. I hope you guys do well tomorrow, and I will see you tomorrow.